Hello everyone and welcome to today's science lesson. So we're going to move on in our science from Earth and space to looking at forces. And today we're going to be looking at explaining the effect of gravity. For a warm-up question, I want you to think about what is a force. So just pause the video and have a think to yourself, maybe make some notes if you want to on the question, what is a force? Okay, let's have a look at that question. Okay, so a force is a push or pull that causes a change in speed, direction, or shape. So we've just got a list here of all the things that forces can do. Forces can stretch an object, like an elastic band. They can tear things, like tearing a piece of paper. They can squash things, like squashing a ball in your hands. They can bend things, maybe like a ruler. They can make an object turn or spin. So if you have a ball on the table and you spin it round, that's a force doing that. They can twist an object, like taking a lid off a jar. They can make an object move. So if you have something on the floor and you give it a little kick, you're applying a force and it's making it move. They can make a moving object go faster. So if something's traveling, like if you're on a swing from your own kicking, and then someone comes along and pushes you, it can make you go faster. And they can also stop a moving object. So if you are on your bike and you put the brakes on, that force is stopping you moving. So those are different things that forces can do. Okay, so before we move on to our activity, we've got a little question for you to think about. So this is just to get your mind in gear. Our question today is kind of taking us back to our space and Earth theme in a way. However, is also looking at gravity, which is a force that pulls us towards the ground. Okay, so I want you to think about this question. What if there was no gravity? What would happen? So have a little think, and then I'll give you a few clues of things you could consider when you think about this question. Okay. So think about, what do you already know about gravity? So think about how it keeps us on the floor. When we jump in the air, we don't just float off. We come back down to Earth. If we throw a ball in the air, it comes back to us. If going back to Newton, if an apple falls off a tree, it lands on the ground, it falls down. It does not just stay hanging there. So how would our lives be affected if that wasn't there anymore? So think about what would be easier and what would be harder without gravity. So if I tried to lift a really heavy box, would that be easier or harder without gravity? Would it be easier because it's easier to pick up? Or would it be harder because it'd be flying off away from me? It'd be hard to keep track on. And if I put it down, would it stay there? I don't know. So how might the absence, so the lack of gravity, change life on Earth? So don't think about it on the moon or on different planets or in space. Think about how no gravity would change our life on Earth. So wherever you are at the moment, you can have a look around the room and think, what would be different if there was no gravity? Okay, let's just look at a little bit of background information about this. So gravity is a force that acts between objects. On Earth, gravity pulls objects, including people, towards the Earth. As well as keeping us grounded, gravity is responsible for keeping planets in orbit around the Sun. You might have seen astronauts on the moon leaping much higher and further than they could on Earth. This is because there is gravity on the moon. But the force pulling them back to the ground is not as strong as it is on Earth. The larger something is, the stronger the gravitational pull, which is why the Earth has a stronger pull than the moon. Okay, so if we just go back to our forces overview, before we start a new topic, we often write down any questions you might have about forces. So this is a great time to pause the video, Take about 3 minutes, write down any questions you have about forces. You could keep them on a post-it note or a bit of paper somewhere and see if you can find them out yourselves. That'd be really good if you could do some research. You could let us know in one of the feedback sessions your favourite question that you've come up with and see if anyone else has any answers, or if we can think of a way of solving it. So what questions do you have about forces? Once you have your questions, you can think about how you would be a detective. So there's lots of different ways of finding information out for scientific research. So I've put 6 of those ways up here. So if you have a question, could it be answered by one of these? So could you carry out a survey, so counting the number of things? So if it was a survey on people's preferences, so do tall people prefer maths to English? And you could carry out a survey on that. So do they prefer maths or English? And does that affect it? I don't know. So is your question something that can be answered by a survey? You need to make sure that you're doing a fair test. So find out what happens to something when we change something about it whilst keeping all the other things the same. So for example, if I'm doing a test on how high different balls bounce, I would, if I'm using different balls, that's the only thing that changes. So I shouldn't start my experiment inside on, for example, a wooden floor and bounce one ball, and then take a different ball and go outside and do it on the grass, and then take a different ball and do it on gravel, and then take a different ball and do it on wood. You should always use the same surface. Once again, with that experiment, if I am seeing how high a ball bounces, I should have a consistent height that I'm releasing it from. So it should always be from the same height. So how would you measure that? Would you use a ruler? Would you mark it on a wall and then drop it from there? Because if I'm testing different balls like tennis balls and footballs, I shouldn't drop one from my ankle and see how high it bounces and then compare it to one that I've dropped from head height. That wouldn't be very fair. So you need to think about how you can keep everything else the same with only changing one thing. I mean, some things might be difficult. If you're doing it outside and the weather changes, does that mean you should stop your experiment and try it again the next day when the weather's the same? Should you always do it at the same time of day? There's loads of things to consider when you start digging down into your experiment. And that's why a lot of experiments are carried out in laboratories where they can control lots of things like temperature and light and atmospheric conditions. And they have all the measuring equipment to make sure everything's perfectly, exactly the same, except for that one variable that they're changing. So one of the other things we can do is do an investigation over time. So watch or measure something over time. So for example, if I was growing a plant, so 3 seeds from the same plant, but I used different soil, and I wanted to see how fast or high it would grow, I'd have to do that over time. I wouldn't just be able to do that once and then not look again. So I could measure it every day. So that would be investigation over time. So seeing how things change over time. So you could also classify things, so putting things in groups. So when we think about science, we quite often classify animals into different groups. So are they a bird? Are they a reptile? Are they an insect? Are they a mammal? And using different things to classify them. So are they warm-blooded? Are they cold-blooded? How does that affect things? So how can you group things by classifying them as different things? You can use a secondary source. So lots of scientists, or all scientists, will do this. Once they've got a new experiment in their mind, they'll do research. They'll look at books, they'll look on the internet for past scientific research papers on those things to see if they can get any information on similar experiments to help with their experiment. They might find that someone's done it before and decide, well, I don't need to do that. Or they might find that someone's done it before and think, I can do it better than that. Or I don't think they were right, so I'm going to do it again. And lastly, pattern seeking. So looking for a relationship between two things. So are two ideas linked? Because this happens, or because this happens, this doesn't happen. So have a little think about that. How could you answer your questions? Being a detective, what would you need to do? Right, let's move on to today's investigation. So our investigation today is to look at this question. How does the surface area of a piece of paper affect how quickly it falls? So that's how much space a piece of paper takes up, how quickly does that affect how does that affect how quickly it falls? So I would pause the video now before I give you a little bit more information. Think, how would you carry this investigation out? So if you had a stack of A4 paper and you wanted to change how much space that A4 paper took up before you see how quickly it falls, what could you do to that bit of paper to change its shape, perhaps, to see if that changes how quickly it falls? So pause the video, have a little think about that. I will tell you that you will need some paper and a stopwatch. So your stopwatch could be on your computer or your tablet or a phone, or you might have a watch. If you just have to count in your head, if that's the only thing you've got, then you'll have to do that. But just know that won't be quite as accurate as if you have a stopwatch or a timer on something else to use. Okay, so there's a video here to watch which will help you think about how you can change things. So this is a stunt artist. So how gravity, the force we're looking at, that's pulling that bit of paper towards the floor. I'll draw a little picture on one of my slides at the moment to illustrate this, how that is affecting a stunt artist. So I'll put this link up and you can follow that and watch it. And the video shows the effects of gravity on a stunt woman when she jumps off a tower from different heights. So see what she keeps the same. So it's a fair test. Okay, so you could link your test to the video. So if a sheet of paper represents a stunt woman, different things you could try. You could fold the paper up. You could crunch it up as a ball. You could leave it as a sheet. You could fold it into quarters. You could make it into a triangle. You could try lots of different shapes. So maybe you could try 5 different shapes and see how that affects how quickly it falls. So if this is a table in the house, and you decide you can always drop your piece of paper from this height. I have my sheet of paper here. Actually, no, I'll put them next to each other. So if I decide I'm going to do sheet of paper, folded in half bit of paper, and scrunched up bit of paper. If I release them, you'll see that they're all going to be released at the same height, and then as soon as I release it, it's going to start heading towards the Earth. And this downward arrow represents gravity, because that is the force that is pulling it towards the floor. And every force has an opposite force. So if gravity is pulling it down, you'll notice that it doesn't instantly hit the floor. And there seems to be a little bit of resistance, and that's because there's another force acting upwards. This is our up thrust, which is pushing back against the paper. Trying my handwriting skills with my mouse. Not too bad, not perfect, but not too bad. So the gravity is pulling the paper down, up thrust is trying to push up against it. So that's our two forces. If we're doing a diagram, we might draw something like this. So you have your different types of paper. You're scrunched up, you're folded in half, you're just a sheet of A4. You could, as I say, put it into a shape, put it into a square, put it into a triangle, put it into other shapes. How does it affect it? So always doing it at the same height, always using the same stopwatch. What else could you keep the same? What else could you change? So have a think about how you're going to keep everything the same except for your paper, what you need to think about when doing your experiment. Other things you need to think about are, how will you record your results? Are you going to use a results table? So for example, we could have time to hit the floor. You would need in your results table, you would need paper type, let's call it paper A, paper B, and paper C. So for all of these, I'm going to need to record the time it takes to hit the ground. So So the first one, maybe A takes 1 second, B takes 2 seconds, C takes 3 seconds. I'm sure it won't be quite as exact as that, but you could record your results like that. And then are you going to repeat it? I would definitely suggest repeating your results, because that will just make sure that your results are more reliable and accurate if you're testing the same thing again and again. So you decide how many times you're going to test it, and then figure out which style of paper is going to fall quickest. So the surface area, how much space it takes up. If you've got a sheet of paper, it's going to take up more space to fold it up bit of paper, and that's going to take up more space than a scrunched up bit of paper. So you could predict, is the scrunched up paper going to fall faster? Why do you think that? Is the folded up going to fall faster? Why do you think that? Or is the sheet of paper going to fall quicker? So before you do an experiment, I think that the larger the surface area, maybe the faster it'll fall or the slower it'll fall. So how could you write down your prediction? Then, like I did in my last slide, think about how you're going to draw it to explain your results, using the word gravity and upthrust like I did on my last slide, and using arrows to show the direction of the force. Remember, gravity pulls it down, upthrust is trying to push it back up again, but gravity's a little bit stronger there. So think about those results. Okay, so that is your experiment today. Let us know how you get on, what results you find. Just to finish up our science lesson today, I thought I'd share with you something amazing that I saw just before Christmas now. So there's a company called Boston Dynamics. I think I've shared with my class before at least one of their videos of their amazing robots. And if you go, I don't want to ruin it, but if you go to this link, which I'll put underneath the YouTube video, and in the team activity, if you go to that link, you'll see some of the amazing things that they have achieved with these robots, and what exciting science we have to look forward to in the future. Okay, so let me know what you think of those robots. Thank you very much for listening, and I very much look forward to seeing what you come up with for your science lesson. Thank you, bye.